Let me review two important products of two vector. One is dot product and the other one is cross product. The dot product of two vector has many use. The first, determine the angle between two lines in space. In biomechanics, many times we have to compute the angle between segments of the body. So for example, if you want to, we have like a leg, and if you want to get the knee angle or ankle angle or hip, so this is hip angle, then many times we want to use dot product to get the angle between the segments of the body. And another use of dot product is resolving a vector into components parallel and perpendicular to a given line. For example, the force is acting along this line, and if you want to determine the force components along the x prime and y prime, then you may want to resolve this vector into the components of x prime and y prime. So in a case, the dot product is very useful. Let's look at the dot product. Right now, let me just make two arbitrarily vector. So this is B point and this is A point, and then I have another vector, so this is O and this is A. I want to, so right now if we consider the origin of the vector, then we can write down this one is RA, B from A, and this vector is R, A from O. So if I want to get the dot product between these two vectors, so I want to get the dot product and these two vectors. According to the formula, so this dot product is the product of the magnitude of each vector and between angle. Right now, let's see what is the between angle between these two vectors. If I just make a line of action for my first vector here, so this vector heading toward A, so if I just shift this vector here, my vector is kind of shifted from here, and then another second vector start from A heading to the B. So right now this data should be your between angle between two vector. However, if you want to get the angle between these side, then once you get data, then you subtract data from 180. That's the way to do that. Or so that's why you can just write down here cosine 180 minus alpha. So if the alpha is of your interest, then you just use these equations to get alpha. Or maybe you can think about this vector like A, B vector, but if you reverse this, the first vector like that, so this is R, O from A, and this is R, B from A, you reverse the direction. So this is the same as negative R, A from O, right? So in a case, if you reverse it, you know that this between angle is alpha. So I'm just using the negative, so negative R, A, O, and dot product R, B, A. In a case, you can just use the magnitude. and this is cosine alpha. And this one you can directly get the alpha by reversing your first vector, so that when you analyze or when you look at when you visualize the dot product, just carefully see the between angle should be what? So depending on your heading or tail of the vector, the between angle is a little bit different. So this is the way to get the between angle using dot product. And then second use of the dot product is resolving a vector into components parallel and perpendicular to a given line. This is a arbitrary vector, let's say v. Okay. And then I have a arbitrary line. So here is any arbitrary line, L, and then let's say this L has a certain unit vector like that. Then I want to resolve or break my vector V into parallel and perpendicular to this L line. Okay. So what does that mean? So if I make a perpendicular line with L, then I want to break my vector along with this component and perpendicular to the L, so which means here. Okay. So let's say this is VP, let's say this is a V normal or perpendicular, and then this is, let's say, theta. Then your V is equal to the VP and VN. So this is the components parallel. This is parallel to a given line. So our given line is L, and then this is the components normal to a given line. Okay. Then how do you resolve this one into the VP and VN side? It's very simple. Actually, you know that since we know this theta, then your V perpendicular cosine theta should be the VP perpendicular. Okay. And then this unit vector of given line is L, if we know the vector L, and divide by the magnitude of L. So let's try to find this one. Then you just do the dot product between your unit vector of given line and then your vector of your interest. So if you follow the formula of dot product, and this one is cosine, what should be a cosine? This one should be theta, because the vector direction is the same as here, so that should be cosine theta. And then we know that the V cosine theta is a VP, so this one is VP like that, and then this one, the magnitude is 1. So your component parallel to given line VP is just dot products of the unit vector of given line and your vector of your interest. Okay, so this is 1. And then let's get the normal components Vn. From your, we know that the V is the VP plus Vn. So we got this component, this is E dot product Vn. So that's why your Vn component is V, your original vector, minus E dot V, right? Let's do the example. In this example, determine these vector components along x prime and y prime. You can use graphical way to solve this one, but we can just use our vector dot product as well. If I just draw this one, let me draw our original coordinate system. So this is original coordinate system xy. Okay. And then another coordinate system is this one. And then our force vector is then since this is a 10 degree, I know that this is 10 degrees. Then this is a 60, and my force vector is here. This is a 60, so I know that this should be 60 as well. This is x prime and y prime, and this is y, and this is x. Okay. Then what is your force vector? I want to write down all the vector in terms of my original coordinate system, which is x, y. So in here, my force vector should be broken into my xy components, and I know the angle 60, so my f vector should be 1 minus 360 and cosine 60i, because if I break this vector along this x, the black line, it should cosine 60 and negative, and plus 360 sine 60j. Okay. My ij is unit vector of my coordinate system. And then I want to resolve my force vector into this x prime y prime. So x prime y prime is kind of given line. And then I want to get the unit vector of my given line. How do you get the unit vector of? So my unit vector is a unit vector of x prime. Then your unit vector E can be represented by your in terms of your xy original coordinate system. So this is cosine 10i and plus sine 10 degree j. Okay, then now we just figured out f and e in terms of my original component. I want to get fp. So what is the component parallel to my x prime? So we know that this fp magnitude is e and f dot products. So if you just do the dot product between these two, you know how to get the dot product between these two vectors. You just multiply this I components plus multiply the y component value. Then if you do that, this one should be, this becomes negative 123.1, and this is just magnitude. So magnitude of your dot product, the magnitude of the result of dot product is negative. That means if you look at this red vector and then E, so right now this is your, let's say 3060 Newton, and this is E, then the negative means your projection to the E line of action is the opposite of the direction of the E. That's why this one here as a negative 123.1. Basically the magnitude is 1, but the direction should be the negative, the opposite to the direction of your E. So that makes sense because the vector 360 Newton vector directed the opposite to the E along this x prime. Then if you want to get the vector component of F, then you just simply multiply your magnitude with E, okay, to get the vector components. So my Fp vector is equal to the magnitude Fp and E unit vector. So if you just do that, negative 123.1, and E vector is cosine 10 degree I sine 10 degree J. So if you do that, you'd get 121.2 I and negative 21.3.8 J. Okay, that's the component along the x prime. This is component of x prime. Then what's the component of along the y prime? So Fn is F minus Fp. So your F is determined by these equations. This here, this is Fp. So you subtract your Fp vector from your F vector. That's your Fn. So if I just show you the answer, this is 9 and plus 300 J. So that's your component of along the y prime. Then let me move on to the cross product. Cross product is very useful in determining the moment of the force or torque or moment. By definition, the cross product of the u and v vector, if I just follow my notation, this one should have those superscript, is equal to the product of the magnitude of two vector, and then the between angle here, u and v between angle theta, and then this is another vector perpendicular to the plane that consists of the v and u vector. And then physically or graphically, the uv cross product refers to the area confined by the u and v vector, and then this area refers to the magnitude of u and v and sine theta, and then however the result is the vector, so it has a vector component as a result. And then please remember that when you use the cross product, you have to follow right hand rule. Then how we determine the resultant direction? Use the following the right hand rule. So if you do the cross product between u and v, your u vector direction is aligned with your index finger, and the direction of the second vector is aligned with your third finger. Then the resultant vector direction is determined by the line aligned with your thumb finger. Okay, so that's the right hand rule. That's why in the cross product it's not commutative, because you change the order of two vector, the resultant direction is opposite. That's why you have to put the negative. However, cross product is still distributive, which means in here you can multiply this one plus you can multiply these two. Cross product of two vectors has many uses. First, determine the moment. We determine the moment. If you look at this one, someone just hold like a ball, and this one is pushing down of your arm to hold this kind of position. How much moment occurring on your elbow to hold this position. In that case, we can easily look at we can easily compute the moment using the cross products. So let's say this is your force and this is the elbow contact point. Then if you know the vector from here to here, for example, then our cross product and force vector, it can be the moment, okay, or torque applying at the elbow contact point. How about this one? If you apply force along this direction, then let's determine the moment. Let's determine the moment at this pivot joint. Then you have to determine what's the r vector from your point to the point of action, and then this is force vector. Then you have to get the cross product between r and f. Let's consider a force vector f and the point P. So this is point P, and then you apply the force like that, and this is like a kind of rod or something and rotating about the P. Then you just define what is your r vector. So this is r vector. So the moment at P is equal to r cross product of f. Okay. Then this one should be r and f and sine theta and k. So this is x and this is y. Then k is coming out of your screen. This direction is coming out of the screen. And what is a theta here? So theta should be this one, because this is vector here, this is r, and this is f. So the between angle should be here, not here. So this is alpha. So let me draw this one again, and this is r vector, and this is f, and this is theta, and this is theta, like that. And then what is f sine theta? What is f sine theta? So f sine theta is, this is f sine theta, right? So which means this one should be 90 degree. So basically your moment m, p is r times f and sine theta. That means you just multiply r and the component of f, that is 90, or perpendicular to your r. Or maybe you can think about what is r sine theta, because this one is equal to r sine theta and f k. So maybe you can just consider this one first. then r sine theta. So if I just make another drawing here, this is r, and then this is f, this is theta, and this is theta. Then r sine theta should be this is r sine theta, okay, and then this is r cosine theta. So r sine theta, this is your p points. This r sine theta will be the 90 degree to the line of your force vector, okay. So your MP is r sine theta component times f, but we know that this component is a 90 degree, between the 90 degree. So that's why in the cross product is basically multiply the 90 degree components. Because of this sine theta, either one of the magnitude or either one of the r or f will become the components that perpendicular to the other kind of vector. So either r sine theta will become this component, or r f sine theta become this component. So anyway, so that is becomes a 90 degree. So again, if you do the cross products between this r vector f, then you consider that you just try to find what is the moment of arm. So the moment of arm is the component of your distance vector that is perpendicular to the line of your action. So that's the moment of arm. So you can get the MP is, if you get this distance d, the moment of arm times f and k, okay. Or maybe if you try to get the 90 degree of your f, so if you can break down your f along this line that is perpendicular to the r position vector 90 degree, then you can still get the MP r, and then this, let's say this is d2 and d2k. So either way will be fine, but I prefer this first method because in the first method you first get the moment of arm between your point of interest, the line of your action. This is the moment of arm.